Hi, so this is a project to share our proposal. The topic is on wood pyrolysis, and this is proposed as a green method of decentralized waste disposal and power generation. And we also get valuable products such as biochar for agricultural use. My name is Chu Jiawei. I'm an associate professor with NTU. This project has collaborators from local SMEs and from overseas R&D companies. The differentiating factors for this proposal is the local context that we are very aligned with. So Singapore aims at net zero emissions in a few decades, and the solutions that we develop has to be fully aligned with Singapore's unique context. The specific problem we are targeting that is unique to Singapore is on the waste, solid waste disposal. So Singapore is a very, very densely populated country. We generate 8,000 tons of solid waste daily. Of these, 40% is incinerated, and the incineration is to reduce the volume by 90% and also to generate power. The problem with such a method is that it gives substantial carbon emissions. To circumvent that and to be aligned with the current grant call on low carbon emissions, we are targeting this specific problem of wood. So Singapore's green city status requires regular tree pruning, and this gives 1,000 tons of waste wood daily. So as a low carbon alternative to incineration, rather than incinerating this 1,000 tons of waste wood daily, we can pyrolyze these wood chips to generate decentralized power and biochar for agricultural use. And pyrolysis, why pyrolysis? Is because it's the most economically viable compared to gasification, biochemical conversion, and various other means. This technology that we developed is also applicable to the substantial waste and sludges from the flourishing pharmaceutical industries in Singapore. The research objectives, we want to firstly understand mechanistically how the reactivity and moisture level of local wood is affected by the operating conditions for pyrolysis, and hence optimize the conditions for the highest yield of power and solid waste disposal. Number two, we plan to develop a comprehensive artificial intelligence-based software to relate the input conditions to outputs, so that as the conditions change, we can tailor it accordingly. The third objective is to test bed this technology on a 150 kilowatt unit to establish a prototype for subsequent commercialization post-project. And how is this significant to the current grant call objective? So Singapore is the world's third most densely populated countries. So an efficient low carbon system for waste management is critical. The current method of waste to energy incineration results in substantial carbon emissions, so it's not sustainable. And to circumvent this, the reduction of the incinerated volume is necessary. And part of this incinerated volume is this wood waste that is generated daily due to this regular tree pruning that we have to do to maintain our garden city status. This tree pruning gives 1,000 tons of solid waste daily. So what this project aims to do is to dispose of this solid wood waste by pyrolysis, and this not only reduces the solid waste that we have to feed into the incinerator, but it also generates decentralized power and also provides biochar for agricultural purposes. So why pyrolysis? Pyrolysis might sound like an energetically expensive process, but it's been reported that 18% of the power generated is sufficient to satisfy the pyrolysis energy requirement, and the yield is very high. It's very attractive. For 1 ton of wood that we pyrolyze, we can get up to 300 kg of biochar. And so compared to incineration, pyrolysis gives higher energy recovery efficiency, lower environmental pollutant emissions, and excellent flexibility for decentralized applications. And then compared to gasification and biochemical conversion, pyrolysis requires the lowest capital and operating costs. And so why are we targeting wood instead of other waste in this incinerated volume? The key reason is because of our tree pruning that is so unique to Singapore. And wood is well acknowledged as a promising solution because it's a renewable renewable resource, and it's easily used as per other conventional fuels. And biomass such as wood is known to have a higher energy density and heating values among the other hydrocarbon fuels. And a farm in Choa Chu Kang has expressed interest in the adaptation of this technology. We'll elaborate more on this later on. And then beyond Singapore, in our neighboring countries, there's a significant potential market in the remote palm oil plantations in, for example, Indonesia and Malaysia. So this is the plan for this proposed project. We are very aware that the need is to reduce the solid waste that we feed into the incinerators because this has a very high carbon footprint. And the solid waste that we are targeting in this proposed project is wood. This is a biomass, and this is a substantial constituent of the solid waste. But the economics of wood pyrolysis for valuable products remains poor. And so this is the challenge that we are resolving in this proposed project. So under work package 1, we'll try to fundamentally and mechanistically understand via experiments and simulations how this wood pyrolysis process is. So we'll run experiments to try to understand the influence of various parameters. We'll characterize the wood, our local wood sources. And then for simulations, we'll carry out multi-scale simulations from the particle scale to the mesoscale to the reactor scale so that we can apply the knowledge gained to the commercial process. Under work package 2, we aim to use artificial intelligence tools to improve the predictive capability of yield based on the inputs. So we know that these wood, the quality and the variety may not be consistent on a daily basis. So we'll have to be able to troubleshoot and be able to predict how much power, how much biochar we are able to get out of the wood that we feed into the pyrolysis reactor. So this software will be very useful in the daily operations of the wood pyrolysis reactor as we commercialize it post-project. For work package 3, we aim at building a pilot scale wood pyrolysis reactor. We already have a quotation from a Belgian company which was involved in the Kepler-Seeger's incinerator project. So we aim to test bed a 150 kilowatt unit to establish a prototype for commercialization. So we already have a farm in Choa Chu Kang has already promised to give us the wood chips. We'll elaborate on this in a little bit. So the final deliverable is a low-carbon fluidised bed wood chip pyrolysis process, a prototype for decentralized power and biochar generation. So more specifically on the test bedding, a Choa Chu Kang farm, which is a contact of one of our collaborators, they've promised to supply us 30 tons per day of wood chips, and they will shred it down for us so that it's easier to feed into our pilot setup. And they've also offered to give us the land space, roughly about 4 of these 40-footer containers, so that we can house this pilot scale reactor that a Belgian contractor will build for us. So this pilot unit will comprise of a fluidised bed furnace and associated blower machinery, secondary combustion chamber and boiler unit, flue gas cleaning plant and fan, turbine generator unit and condenser, and electrical switch gear and load bank. So this is a general overview of the test bedding that will be investing a sizable amount of this budget too. So this is the shredding of the chips at this Choa Chu Kang farm. In terms of deliverables, midterm, we aim to get insights into the different mechanisms of wood pyrolysis. There are various mutually interacting processes. We will try to identify the influence of various parameters so that we know which are the most dominant ones to control. And we also seek a fundamental understanding of these processes, which will contribute towards the design of a high-efficiency system. We also aim at designing and scaling up of the optimized high-yield fluidized bed pyrolyzer. We will study the hydrodynamics systematically, and then we'll optimize the design parameters. So the lab scale model will lay the foundation for the development of the pilot scale and for future commercialization. And then thirdly, the software based on artificial intelligence tools, which is a user interface in future when we commercialize this reactor. So this software will allow for the prediction of yield based on the specific inputs, knowing that the wood properties and will change potentially on a daily or even hourly basis. At completion, we aim to have a technology for future scale-up and other applications. Other applications, for example, coal gasification, solid waste gasification, as well as treatment of pharmaceutical waste, knowing that the pharmaceutical industry is a dominant industry in Singapore and waste disposal costs have skyrocketed recently. And also manpower and intellectual property development. We aim at high quality publications, training of postdoctoral fellows who will contribute towards the commercialization aspects post-project. And then we do expect these trained personnel to participate in the business development activities post-project. And commercialization, we will have a set of heuristics for the commercialized fluidized wood chip pyrolyzer. So this project is based off a very strong team with a combined experience of more than a century. I'm from an IHL from NTU. We have 2 overseas R&D companies and 3 local SMEs. All of us have collaborated and interacted at some point, so we are not strangers to one another. So my name is Chu Tawai. I'm from NTU. I have 15 years of research experience in process understanding and design. Ray Coco is from the US. He helps this research company. He has more than 30 years of experience in multi-phase flow. Dan Thiru is a co-founder of Bluestem Private Limited in Australia. He's an expert in applying AI to model and analyze complex processes such as this. Hongge is helms Gramtech New Water. He has more than 50 years of experience in implementing engineering innovations. He was one of the pioneers in the incineration scene in Singapore in the late 70s. And he also developed a fluidised bed toxic waste plant in Jurong Island with Sembcorp in 2000. Tak Sing is an independent project developer with more than 30 years of engineering experience. He co-developed a biomass plant to convert wood chips from NParks waste into biochar. Angie is from Alpha Grace Envirotech. She has more than 20 years of experience in waste treatment. Specifically, this company, of which she's a director in, develops de-centralized incinerators of 1 ton per day and 5 tons per day capacity. The waste material process ranges from domestic waste to biomedical waste. In the following, we'll look at a video that showcases the expertise of Hongge in bringing this project further into the commercialization phase after the end of this project. And we'll also look at a video that showcases AGE's capability in and innovations in waste treatment. So in summary, this project is on developing a fluidised bed pyrolysis process as a means of green, decentralized solid waste disposal and power generation. The specific problem we are targeting is this reduction of solid waste incineration, whose carbon emissions is significant. And we are targeting wood because it's a substantial constituent of solid waste, especially in Singapore because of the tree pruning. But then the economics of wood pyrolysis for valuable products currently remains poor. So we target a fundamental understanding through experiments and simulations, and then developing a software based on artificial intelligence and the fundamental insights gained to maximize the yield and to be able to operate the pyrolysis reactor on a daily basis. But package 3 is on test bedding this prototype in order to this pilot plant in order to establish a prototype for future commercialization. The deliverable is a low carbon fluidised bed wood chip pyrolysis reactor for decentralized power and biochar generation.